All right, so if you watched the demonstration video, tangent isn't brand new to you, but if you didn't, this is just kind of a quick intro to a tangent graph. Not as common as the sine and cosine ones, like they don't occur in nature quite as much, but they are there, and then we do end up using them quite a bit as time goes on. We won't do any of the transformations with them. You can try a couple of them on your own. They're not any different than they were with sine and cosine. So if you can do the sine and cosine ones, you can do the tangent ones. It's just tangent's kind of a, like I said, a weirder graph. You'll notice in the table that I made that the x values that I'm going to use are different. Okay, because tangent, again, acts a lot differently than sine and cosine do. And if you happen to have your version of the unit circle, you will be able to see this a whole lot better than I'm going to be able to describe it right now. But we'll do, again, the best that we can with it. But the important points for tangent actually happen a lot more frequently. So if you do happen to have your old unit circle, you'll notice a couple more spots, actually about twice as often, that you hit a point that's kind of valuable. Okay, the first one that we hit on the unit circle that's going to be notable is at 0 degrees or at 0 radians, tangent is 0. So if I come over here, this one is 0. And if you don't just know it or don't have it written down, you can look on here and say, oh yeah, tangents are the y's divided by the x's. If I take the y divided by the x, I'm going to get 0. Okay, the next one of significance is at pi over 4. If I go to pi over 4 and I take the y divided by the x, I'm going to get 1. So if yours doesn't have it on there, if you don't have yours, again, the tangent there was 1. At pi over 2, 1 divided by 0 is undefined, which is a weird thing to graph until we connect it to what we did back in chapter 8. So I'm just going to do one of these guys for the moment. Undefined. And it's written kind of weird because you don't actually see these on the unit circle, but because well, when we graph it, we'll see why we did this. We're going to go to negative pi over 4, and negative pi over 4 is negative 45 degrees, which is right down here. 7 pi over 4 and negative pi over 4 are the same spot. The tangent, if I have it on this location, this divided by this is going to be negative 1. And for some reason that 1 looks a little weird, so, and I didn't actually make it better, so that's sad. Let's try that again. So it's just a 1. There we go. And then at negative pi over 2, that would be this guy, but flipped down here, negative 90 degrees. I divide these again, I get an undefined one. Okay, so the reason that I went backwards is to have that happen. I want it to kind of be bookended with undefined. And if you've watched the demo video of tangent, you saw that it was broken up into like all of these separate chunks that just keep repeating. So that's what I'm going to do. So I'm going to graph these 3 middle points here, 0, 0, and then pi over 4, 1. So this is the first time we've actually used these ones for our original graph. So pi over 4, 1, and negative pi over 4, negative 1. So negative pi over 4, negative 1. So at the moment it looks like a straight line. It's definitely not if you've, again, messed around with this a little bit at all. And then these undefines. Those undefines take us back to, again, to chapter 8. If we have a point that we cannot graph, we either have a hole or an asymptote there. And with a tangent graph, it's an asymptote. Okay, and I'd notice that, like if I started trying to plug numbers into tangent, like this is tan of 45, pi over 4, 45 degrees, tan of 45 is 1. If I tried tan of 60, I'd get something a little bit bigger than 1. Tan of 70, 80, 85, all of a sudden those numbers are going to start getting really, really big. Like if you plugged in tangent of 89.99 degrees, you're going to get a really big number. But then you're going to try to plug in tangent of 90 and you're not going to get anything. Okay, so it's taken off really, really fast. And then all of a sudden at 90, we don't exist. So that is the very definition of a vertical asymptote. So I'm going to change color here to put that in. Again, going to be a little bit gross to try to draw, but you hopefully do a dotted line because that's what asymptotes typically take on the form of, or that's how we identify them. But if you do a solid one, it's not that big a deal either. and go to negative pi over 2, and I have the same thing. Oof, missed that point. So I'm trying to go fast so this video isn't super long. But those are asymptotes there. And I go back to my original blue color. And what's happening in between here is, again, as it gets closer to 90 degrees, it's taking off really, really fast. And then it's going to level off. And as it goes near negative 90 degrees, it's going to head really, really fast against here. So what we remember about asymptotes is that our graph gets right up against them, but does not cross them. So they're kind of like guides. Okay, so if I try to do my best to sketch this, it's going to look something like this. And then it's going to curve, hit those 3 points, and that worked way better than I thought it would. So yeah, that is a tangent wave. It kind of ends up looking like a lightning bolt type thing is kind of how I think of it. And just like sine and cosine, that's going to repeat as well. So like if I go to 3 pi over 4 on the graph, so on my unit circle, 3 pi over 4, and I divide these, I'm going to get negative 1. So my tangent of 3 pi over 4 is negative 1. So I'm not going to put that one on the table, but I'm going to graph it. If I do pi, tangent of pi is 0. If I do 5 pi over 4, I get positive 1. The tangent of this guy is positive 1 again. Okay, so notice over here I had negative 1, 0, 1. Negative 1, 0, 1. And then an asymptote. Here I've got negative 1, 0, 1. And if I'm looking at this right, the next thing that should happen, because it's cyclical, because it repeats, is another asymptote. So at 3 pi over 2, if I divide these, or if I just look on my old unit circle, I will have it be undefined. So I'm going to go over here again, switch to red, at 3 pi over 2. It is, once again, undefined. Go back. So notice we have the exact same pattern we had in this central one. Okay, and that's exactly what's going on. It's going to get right up alongside here, swoop down, curve through, and go. Okay, and if I wanted to repeat it, hopefully 7 pi over 4 then would repeat this same pattern. Asymptote, negative 1, 0, 1. Asymptote, negative 1. So tan of 7 pi over 4 is negative 1. 2 pi should be the same as 0, so 0. And then 1 would be the next one, so it'll be going like this, and then off the graph, and I'll hit that next one and up. Okay, and if I go in reverse, it should work in reverse. So asymptote, 1, 0, negative 1. Asymptote, 1, 0, negative 1. And then the next one, once again, should be asymptote. So as we go across, we keep repeating the exact same pattern. So it looks very different. And this one really looks different because I don't have a point here to like keep it steady. But it's the same exact idea. This very cyclical thing because we end up hitting coterminal angles, the same reference angles, and we get this kind of cool wave that goes. And I can do all the same things I did to sine and cosine with tangent. I could shift it left and right by changing what's on the x. I can move it up and down by adding something to the end of it or subtracting something. I can multiply something on the front of it that'll stretch it out. That'll stretch these ones up to maybe 2s or 3s or 10s or whatever. I could reflect it and flip them. All of those things are possible with tangent as well. Nothing changes. You just kind of take this main table or you take the picture and you make those moves with it. But that's enough on the graphing into things. I don't need to really add a whole lot more to it because this has hopefully just been a really good introduction to all these things so that when you see them next year, you're not as freaked out as you are maybe when you're seeing them right now. So it's kind of taking the top off of those. So hopefully that helps.